I've been experimenting with different designs of 3D printed gearboxes, but one challenge has been particularly difficult to solve: getting a 3D printed gearbox to spin extremely fast. So in this video, we only have one focus: speed. It'll be powered by this beefy 350 watt DC motor, variable speed controller, 24 volts with extra long wires for safety. I've quickly replicated the DC motor in Fusion 360, but how exactly should we approach this design? Let's start off with testing the DC motor. The DC motor speed controller is really simple. Connect the positive and negative of your DC motor to one side, and the positive and negative of your power source to the other side. We can measure the actual speed of the motor using some reflective tape and a tachometer. So it looks like with no load we could get about 3,300 RPM. So we're starting with 3,300 RPM. We could use a gear ratio to up the speed. 4:1 gives us 13,000. Let's try 20:1 gear ratio equals 66,000. 25 equals 82,000. 30 gives us 99,000. And 32:1 gear ratio will give us over 100,000 RPM. But can we actually get it to spin that fast? Assembly for this project is fairly straightforward. The metal rods fit snugly in the holes to keep them from slipping out, and the DC motor is bolted to the base. The main drive gear easily attaches to the motor's axle with a hex nut. So here's basically how it works. This big gear meshes with a small gear, which makes it go faster. Then we have another big gear meshed with another small gear, which makes it go even faster, and another big gear meshed with a smaller gear, which makes it go even faster, and all the way down until we get to the very last gear. So basically with the drive gear, it gets faster and faster and faster, all the way until we get to this tiny little gear on the end, which should go extremely fast. And as you can tell, the axles fit very snug. This is exactly what we want. So as we slowly increase the speed, there comes a point where the motor actually stalls. With 5 gears, there's simply too much friction. However, we did get to about 11,000 RPM. For this next test, let's go ahead and remove the last gear and see how fast it'll spin. Right here, it's spinning about 21,000 RPM before it shuts off. Let's go ahead and try it again. This time it got close to 23,000 RPM. And I'm calculating this by measuring the speed of the input gear and multiplying it by the gear ratio. That gives us the output speed of the last gear. This time the drive gear got up to 1449. Let's plug that into our calculator. So this time we get 40,000 RPM. But what would happen if we remove one more gear? So as you can see, the RPM is able to get a lot higher, this time about 3482. But because we removed a gear, we have to change the gear ratio. Let's plug in 3482 and we get the drive gear speed times the gear ratio is 43525. So the lesson that we could learn here is that just because you have a really high gear ratio doesn't mean you could get the last gear to spin extremely fast. It would actually be much easier to get a gear to spin fast by using a really fast motor. For example, this motor already spins at 35,000 RPM. So just with a 2-to-1 gear ratio, it'll spin 70,000 RPM. So for now, we'll have to stick to our new record of 43,525 RPM. This video was made possible by our friends over at Micro Center. Micro Center is a really great place to go for anything electronics related. Whether you want to buy a new 3D printer in person, or if you need to pick up some filament while you're on the go, or if you just want to build the most epic custom PC. Micro Center is your one-stop shop. And if you don't have a Micro Center nearby, you could always order online at microcenter.com.